problem 26 in section 1.1. So ask us to prove the Rolle's theorem by verifying the following. So I think there's some typos in the book. We're going to use the correct one as I'm showing here. So the first use the Rolle's theorem, the standard Rolle's theorem to show that so let me just maybe just go to this so you know what I mean. So in the general theorem, we say that f is n times. I'm sure if n is enough. Yeah, fn is n times differentiable, and for these points, x0 through xn, so consider them as sorted. x0, x1 through xn, they are distinct and sorted. For x0, which is called a, for xn is b, and we know the function f is 0 at those n plus 1 points, and f is n times differentiable. Then the purpose to show that there must be a point between a and b such that the nth order derivative of f will be 0 there. Right? That's the conclusion of the Rolle's theorem. So how do we prove that? So in the first step, we'll look at this because the function f is 0, taking value 0 at its n plus 1 points. Then there's n intervals. x0, x1, they can form an interval, right? x1, x2 can form an interval. And on each of these intervals, the f is 0 at those two endpoints. So by Rolle's theorem, there exists a point in each of these interval. So this is the interval formed by xi minus 1 xi. There must be a point in between them, I call it zi, such that the f prime at zi is equal to 0. So now we have n intervals, and each interval has 1 point, so that's how we get this n points, zi, such that the derivative is equal to 0. Then next, since we know the f prime is 0 at this z1 through zn minus 1, sorry, it should be zn. Should be zn here. Okay, so for this, we know that the f prime is 0. Okay, and also so for on each of this, so you get because they are from the distinct disjoint intervals as earlier, so these points are distinct, and they're also sorted because they're in the sorted, they're nested in the sorted intervals. So that's why they are sorted distinct. And when we look at the z1, z2, we know that f prime is 0 at these 2 points, and f double prime exists, so that means there exists a point between z1, z2 such that f double prime is 0 there. Okay, so in general, for those, there are n points here, so they form a n minus 1 intervals, and for each of the interval, we can find this wi over that interval, so the f double prime will be 0 at this wi. Okay, so you can just continue this process. You can see that when you have j, so this is the number of derivatives you're going to take. Every time you take a derivative, you're going to have one fewer point left. And so for j equals to 1, that's one case we showed earlier. In this case, when j equals to 1, we know that there will be n points left. So it's n minus j plus 1 when j equals to 1, just n discrete points, so that f prime is 0 there. Okay, and then when j equals to 2, that's what we did here. And in general, you can do this up to the nth order. Then you have n minus n, j equals to n now, n minus n plus 1. Then you have just 1 point where the nth order derivative will be 0 there. Okay, that is the generalized Rolle's theorem.